Welcome back to the deep dive. Today, we're really getting into the nuts and bolts of something crucial for flying safely and efficiently: engine instrumentation.
Absolutely. It's fundamental.
And this isn't just about, glancing at a dial. It's about understanding what the engine is actually telling you. Is it happy? Is it about to give up?
Exactly. It's a language.
So for all of you deep in ATPL theory prep, our goal today is simple. Break down these instruments, how they work, the physics, why they matter, especially under pressure. We want you to nail these concepts.
And these instruments, they really fall into two key groups, which helps to understand their jobs.
Okay, let's start there. What are the two main types?
Well, first, you've got your performance indicators. These are the ones showing you basically how much push or power you're getting right now.
Like thrust.
Precisely. Things like EPR engine pressure ratio, or N1, the fan speed. You use these to set takeoff power, climb power, that sort of thing.
Makes sense. Performance. What's the other category?
The other side of the coin is engine condition indicators. These guys are all about engine health. Are things getting too hot? Is the pressure okay? Are the insides spinning within limits?
So things like temperature, oil pressure.
Exactly. EGT, exhaust gas temperature, that's a huge one. Oil pressure, oil temperature, the speed of the inner parts of the engine, like N2 or N3. They're watching for signs of stress or impending problems.
So performance tells you how hard, condition tells you if it can keep going.
That's a great way to put it, yeah.
Now, before we dive into specific measurements, how we see this information has changed a lot, hasn't it? From old school dials to modern screens.
Oh, massively. We started with the traditional analog display, the clockwork cockpit, a dedicated physical gauge for pretty much everything, lots of RAN dials.
Very mechanical.
Very. And now the standard is the electronic display, the glass cockpit, using CRT screens initially, but now mostly high-res LCDs.
Which lets you combine information, right? Cleaner panel.
Huge benefits. Integrated displays, color coding for warnings, less clutter, automated alerts. The measurement still happens out at the engine, but how it's presented is all digital.
But even on the newest jets, they don't completely ditch the old ways, do they? There's always some backup.
No, absolutely not. Redundancy is king in aviation. Regulations and just plain good sense mean that even the most advanced glass cockpits keep a few conventional analog-style gauges.
Standby instruments.
Right. Usually for critical things like airspeed, altitude, attitude, and maybe one key engine parameter. If the main electronic displays were to fail, power loss, computer glitch, whatever, you still have the bare essentials to fly the plane safely.
Okay, let's get into the performance side. For jets and turbofans, it all starts with thrust. How do we measure that push? What's the basic idea?
Well, the simplest concept is just measuring the pressure coming out the back end. That's the P7 gauge.
P7, meaning position 7 in the engine.
Sort of, yeah. It denotes the station, the jet pipe exit pressure. It directly measures that pressure. Units can vary. You might see inches of mercury, psi, sometimes just a percentage of the maximum thrust.
So a direct pressure reading. Simple enough.
It is, but it's not always the most precise indicator of the actual thrust being produced, especially across different altitudes and temperatures. Which leads us to the more common standard on modern turbofans.
The engine pressure ratio, or EPR gauge, I feel like this one is key.
It absolutely is. EPR gives you a ratio. It compares the pressure coming out of the engine to the pressure going into the engine.
Okay, so outlet pressure divided by inlet pressure.
Essentially, yes. P out divided by P in. Typically, that's the total pressure at the jet pipe exit, or sometimes an integrated value from the turbine discharge and fan outlet divided by the total pressure measured right at the engine intake, usually the compressor inlet.
It's comparing what went in versus what came out. How much the engine boosted the pressure?
Exactly. It gives a much better indication of the engine's actual work across different conditions than just measuring the outlet pressure alone.
Seems straightforward on paper, but measuring those pressures accurately, especially the inlet one, which changes with airspeed, and then calculating the ratio in real time, that sounds complex.
It involves some clever tech. Modern systems use transducers. These are little devices that convert the physical pressure.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best